Today, we will be talking about how to solve simultaneous equations. We have three simultaneous equations right here that we are going to solve on the left side of the whiteboard. And the way to solve simultaneous equations is to move every single term with an unknown variable letter to one side of the equation, and every single term that does not contain a variable letter but with numbers only to the other side of the equation. And the way that we want to do this is to move all of the terms with unknown variable letters to the left side of the equation, and every single term with only numbers and numbers only to the right side of the equation. So let's get started. So first up, we have 3s plus 2t is equal to 12. So we have 3s plus 2t is equal to 12. And we also have 4s minus t is equal to 5. So 4s minus t is equal to 5. And for this first set of problems right here, we do not need to rearrange anything because all of the terms with unknown variable letters are already to the left side of the equal sign, and all of the terms that contain numbers only are already to the right side of the equation. Now, the way that we want to do this is that we want to make the number part of the term that contains the unknown variable letter that we're trying to solve exactly the same as the other unknown variable letter that is the same unknown variable letter as the one before that. So we can do that by using this one, which is s, or this one, which is t. It doesn't matter, but we have to do it to one of them. So let's just suppose we do it for the first one, for s. So 3s and 4s, the s is already the same. However, 3 and 4 are not the same. And what we have to do is to make them the same. And so therefore, the way to do it is to multiply the first equation by 4 and to multiply the second equation by 3. Because 4 times 3 gives us 12, so this will become 12s, and 3 times 4 also gives us 12, so which will result in this 4s becoming 12s as well. So for the first equation, we're going to have 12s, because 4 times 3s gives us 12s. 4 times positive 2t gives us positive 8t. What does that give us? We cannot directly write 12 because 12 is also within the brackets. So we have to multiply 12 by 4, which will give us 48. For the second equation, we have 3 times positive 4s, which, just like this part right here, it's going to give us positive 12s. 3 times negative t gives us negative 3t. And last but not least, 3 times positive 5 gives us positive 15. Now what we want to do is that we want to subtract, not add, but subtract this second equation right here from the first equation in order to get rid of the 12s and the 12s. So for that reason, we are going to subtract. So we're going to put a minus sign right here, draw a straight line right here. So now 12s and 12s officially cancels each other out. Positive 8t minus negative 3t. That gives us positive 11t. Positive 48 minus positive 15. That gives us positive 33. So now we have 11t being equal to 33. And what we want to do is that we want to isolate t. So we're going to divide both sides by 11. The 11 and the 11 cancels each other out. 11 divided by 11, that leaves us with just 1. 33 divided by 11 gives us 3. And this would give us 3. So therefore, for the first problem, t is equal to positive 3. But we also have to solve for the variable letter s. What is s equal to? Well, we can use either the first equation or the second equation. It doesn't matter which one we use. Both of them will be able to tell us what s is equal to as long as we plug in the number 3 for t. So let's suppose we use the first equation. So 3s plus 2t gives us 12. So 3s plus 2 times t is equal to 2 times 3, which gives us positive 6. This gives us 12. Now we're going to move positive 6 from the left side of the equation to the right side of the equation. So now this is gone, and this would be negative 6. So 3s is now equal to 12 minus 6, which is 6. Divide both sides of the equation by 3. 3 and 3 cancels each other out, which leaves us with s being equal to 6 divided by 3, which gives us 2. And so therefore, for the first equation, for the first set of simultaneous equations, s is equal to positive 2 and t is equal to positive 3. Now let us solve the second set of simultaneous equations. So once again, what we want to do is that we want to move all of the terms with unknown variable letters to the left side of the equation, leaving the right side of the equation with numbers only. So first of all, 5x is equal to 2y. This would become 5x minus 2y is equal to 0. And the second equation is 3x plus 7y is equal to 41. Now, instead of making x the same, which we could, but now let's just suppose we're going to make the numbers in front of the y the same. And 2 and 7, we're going to make them 14. So in order to make 2 and 7 14, we have to multiply the first equation by 7, and we have to multiply the second equation by 2. So now 7 times 5x gives us 35x. Minus 2, so negative 2y times positive 7 gives us negative 14y. And 0 multiplied by anything still results in 0. Positive 2 times 3y gives us, positive 2 times 3x gives us positive 6x. Positive 2 times positive 7y gives us positive 14y. And this is equal to positive 2 times positive 41, which gives us positive 82. Now, we have to get rid of the negative 14 and positive 14. And to do that, we are going to add the two equations. So we're going to have 35x minus 14y equals to 0 plus 6x plus 14y is equal to 82. So now, positive 35x plus positive 6x, that gives us positive 41x. Negative 14y plus positive 14y, that gives us 0, so we don't have to write anything. So this is the only term to the left side of the equal sign. 0 plus positive 82 still gives us positive 82. Now, to isolate the x, we're going to divide both sides of the equation by 41. The 41 and the 41 cancels each other out, leaving us with x is equal to 82 over 41, which gives us 2. And so therefore, for problem number 2, x is equal to 2. Now, all we have to do in order to solve for y is to plug in 2 for the variable letter x in one of the equations. So 3 times x is equal to 3 times 2, which gives us 6, plus 7y is equal to 41. Now we want to isolate positive 7y. So therefore, positive 7y is equal to, we're going to move the positive 6 from the left side of the equation to the right side of the equation. So now the right side of the equation becomes 41 minus 6. And that gives us 35. Now, in order to isolate the y, we have to divide both sides of the equation by 7. And that, so the 7 and the 7 cancels each other out, which means that y is equal to 35 divided by 7, which gives us 5. Now let us solve the last and final problem. So once again, what we want to do is that we want to move all of the terms with unknown variable letters to the left side of the equation, and all of the terms that includes numbers only to the right side of the equation. So therefore, for the third practice problem, we will have negative 5c, because we will have moved positive 5c from the right side of the equation to the left side of the equation. We're going to have negative 3d and positive 1 when moved from the left side of the equation to the right side of the equation becomes negative 1. Here, for 2d plus c, we're going to write it the other way around. We're going to put c ahead of 2d, just for consistency purposes. So we're going to have positive 1c, which is just c, plus 2d is equal to positive 4 moved from the left side of the equation to the right side of the equation becomes negative 4. Now, let's suppose we're going to make this term right here and this term right here exactly the same. And to do that, what we're going to do is that we will leave the first equation alone. However, as for the second equation, we will multiply everything, every single term, on both the left side of the equation as well as the right side of the equation by negative 5. So now the first term remains exactly the same, which is negative 5c minus 3d is equal to negative 1. However, the second term now becomes, well, negative 5 multiplied by positive 1c. This gives us negative 5c. Negative 5 times positive 2d gives us negative 10d. And last but not least, negative 5 times negative 4 gives us positive 20. Now we're going to put brackets around both sets of equations. And in order to get rid of the term negative 5c in both equations, we must either add the two equations together or subtract one equation from another. Which one do we choose? Well, let's take a look at it carefully. We have negative 5c in the first equation and negative 5c in the second equation. If we add the two equations, negative 5c plus negative 5c, that would become negative 10c. And we don't want that. We want the term to be 0. And so therefore, we are going to subtract the second equation from the first equation. So now, negative 5c minus negative 5c, that would be the same thing as negative 5c plus positive 5c, which will give us 0. And since it's 0, we do not have to write it. Negative 3d minus negative 10d, that will be the same thing as negative 3d plus positive 10d. And that gives us positive 7d. Negative 1 minus positive 20, that gives us negative 21. Now we're going to isolate the variable letter d by dividing both sides of the equation by positive 7. The 7 and the 7 cancels each other out, which means that we are left with d being equal to negative 21 divided by 7, which means that d is equal to negative 3. So d is equal to negative 3. Now let us solve and see what the variable letter c is equal to. So let us use the second equation to solve for the unknown variable letter c that we're looking for. So 2d plus c plus 4 is equal to 0. And so therefore, this means that c is equal to, so we're going to move the positive 2d from the left side of the equation to the right side of the equation, and we'll do the same thing with positive 4 as well. So therefore, c would give us, c is equal to negative 2d minus 4, which is equal to negative 2 times negative 3 minus 4. Negative 2 times negative 3 gives us positive 6 minus 4. 6 minus 4 gives us positive 2. And so therefore, C is equal to positive 2. And this is how to solve simultaneous equations.